Hello everyone, welcome back to Operating System tutorial series. In this video, we will study operating system services and user operating system interfaces. In this particular figure, a view of operating system services is shown. Operating system provides environments in which programs run and services for the users of the operating system. It includes user interfaces, program executions, input-output operations, file system manipulation, communications, and error detection. We will study these things one by one. First of all, user interfaces. User interfaces means by which users can issue commands to system depending on the system. These may be command line interfaces, for example, different types of shells like SH, CSH, KSH, TCSH, etc. GUI interface, for example, Windows, X Windows, KDE, Genome, etc. or a batch command system. The latter are generally older systems using punch cards of job control languages JCL, but may still be used today for specialty system design for single purpose. Now, program execution. The operating system must be able to load a program into RAM, run the program and terminate the program either normally or abnormally. Input-output operations. The operating system is responsible for transferring data to and from input-output devices, including keyboards, terminals, printers, and storage devices. File system manipulation. In addition to raw data storage, the operating system is also responsible for maintaining directory and subdirectory structure, mapping files names to specific blocks of data storage, and providing tools for navigating and utilizing the file system. As far as communications are concerned, inter-process communication IPC, either between processes running on the same processor or between processes running on separate processor or separate machines, may be implemented as either shared memory or message passing, or some system may offer both. As far as error detection is concerned, both hardware and software errors must be detected and handled appropriately with a minimum or harmful repercussions. Some systems may include complex error avoidance or errors or recovery systems, including backups, RAIDs drives, and other redundant systems. Debugging and diagnostic tools aids users and administrators in tracing down the cause of the problems. Other system aids in the efficient operation of the operating system itself are resource allocation, accounting, protection, and security. As far as resource allocation is concerned, for example, CPU cycles, main memory, storage space, and peripheral devices. Some resources are managed with generic systems and other with very careful design and specially tuned systems customized for particular resource of the operating system environment. Accounting, keeping track of system activity and resource uses, either for building purposes or for statistical record keeping that can be used to optimize future performance. Protection and security. As far as protection and security are concerned, preventing harm to the system and to resources either through wayward internal processes or malicious outsiders. Authentication, ownership, and restricted access are obvious parts of the system. Highly secure system may log all process activity down to the details, and security regulation dictate the storage of those resources on permanent non-erasable medium of extended time in secure facilities. Now we come to user operating system interfaces. As far as user operating system interfaces are concerned, there are two possibilities. One is command interpreter and the second one is graphical user interface, which we call GUI. So first, command interpreter. It gets and processes the next user request and launches the requested programs. In some system, the command interpreter may be incorporated directly into the kernel. More commonly, the command interpreter is a separate program that launches once the user logs in or otherwise accesses the system. Unix, for example, provides the user with a choice of different shells, which may either be configured to launch automatically at login or which may be changed on the fly. Each of these shells uses different configuration file of initial settings and commands that are executed upon startup. Different shells provide different functionality in terms of certain commands that are implemented directly by the shell without any external programs. Most provide at least a rudimentary command interpretation structure for use in shell script programming, loop, decision constructs, variable, etc. An interesting distinction is the processing of wildcard file naming and input-output redirection. On Unix system, those details are handled by the shell, and the program which is launched sees only a list of file names generated by the shell from the wildcards. On a disk operating system, DOS system, the wildcards are passed along to the programs which can interpret the wildcards as the program sees. The Bourne shell command interpreter in Solaris 10 operating system is shown in this figure. Graphical User Interface GUI, generally implemented as a desktop metaphor with file folder, trash can and resource icon. Icon represented some items on the system and respond accordingly when the icon is activated. First developed in early 1970s at Xerox PARC research facility. In some systems, the GUI is just a front end for activating a traditional command line interpreter running in the background. In other, the GUI is a true graphical shell in its own right. Mac has traditionally provided only the GUI interface. With the advent of OS X based on Unix operating system, a command line interface has also become available. Because mice and keyboards are impractical for small mobile services, these normally uses touch screen interface today that responds to various patterns of swipes or gestures. When these first came out, they often had a physical keyboard and or a trackball of some kind of built in, but today a virtual keyboard is most commonly implemented on the touch screen. The iPad touch screen is shown in the figure. Choice of interface. Most modern systems allow individual users to select their desired interface and to customize its operation, as well as the ability to switch between different interfaces as needed. System administrators generally determine which interface a user starts with when they first log in. GUI interfaces usually provide an option for terminal emulator window for entering command line commands. Command line commands can also be entered into shell script, which can then be run like any other program. The Mac OS X GUI is shown in the figure. So in this particular video, we have learned about operating system services like user interfaces, program execution, input-output operations, file manipulation, communications, and error detection. We have also learned about user operating system interfaces like command interpreter, graphical user interface, GUI, and choice of interfaces. I hope you liked this video. Thanks for watching. See you in the next video.